Alright, welcome to Section 8.5. These are the type of days that I really like, because if you guys get this section done, you are one test away from being done with the second term. Alright, that's pretty cool. Hopefully this will be your second math class, second math credit of the year. I really like it when people get credits, you know me. All right, let's go ahead and look at what we're dealing with today. We are solving systems of inequalities now. All right, so we've worked with systems of equations. We're going to take today talking about systems of inequalities. Okay. Now, if you remember, when we were graphing inequalities, two variable inequalities, we would go through our couple. Of course, it's something where we had steps. But remember, this right here tells me that it's a dashed line. So that means dashed. Okay, and it's in slope-intercept form. So I'm just going to graph that. We start at 3, and we go down 2 and over 1. Okay, so I have this one right here. It's a dashed line. Remember that. I always forget when I go to graph it. Let me go ahead and make sure that I'm really on these. So a dashed line through here. Oh, that's a really long dash right there. Anyways, okay, now I want to test a point. So I'm going to test, and we can test 0, 0 because it's not on that line. So is 0 less than negative 2 times 0 plus 3? That goes away because we're multiplying by 0. So 0 is less than 3. So I need to shade where, I'm actually going to make it a little more of an angle. Shade where the point 0, 0 lives, along with all its buddies that are going to make that inequality true. Any number in this shaded region will make that inequality true. Okay. Now what we're going to do is we're actually going to add a few more inequalities to this graph and really look at what happens. Okay. So the next one we have is x is greater than negative 4. I'm going to use a different color for that. So x is greater than negative 4. Negative 4 is right here. Okay. And we're going to have a vertical line, and it's going to be dashed. So we're looking at dashed vertical line right through here. Okay, that goes that way. And now what we get here is we get everything bigger than negative 4, so that's going to be off this direction. So this is going to get a little bit messy, but you're just going to have to bear with me for now. Okay, so I have one graph that's going this way, another graph that's going that way. Let's go ahead and add one more. Let's just make this real fun. Now I need any y's that are greater than or equal to 1. Okay, well, that's a horizontal line right through here. It's a solid line. It goes right through there, and I need the ones that are bigger than that. So they all live up above here. Let's go ahead and try to shade that in. We have such a mess going on here, but it's okay. I'm going to teach you a way later that makes it less messy. Okay. Now, when you're talking about the solution to a system of inequalities, so a solution to a system of inequalities is where all solutions overlap. Okay, so where all those other solutions overlap is actually going to be the solution of our system of inequalities. So remember, we graphed multiple inequalities on a number line, and we had that and statement and the or statement. all this shading that we have on here, which actually covers all of the graph, would give us an answer for an OR statement. But whenever we're dealing with a system of inequalities, it's just an AND statement. So really what I'm looking at is I'm only looking at where all three overlap. So where I have red, blue, and black. And that's this section right in here. Kind of tough to see, but it's really just this section that lives right here. Any points that live in this green region are going to be answers that are points that make both, or sorry, not both, but all three of these inequalities true. Okay, so a little bit tough to look at, and like I said, I'm going to go ahead and show you a way that I use to keep things a little bit simple. Let's go ahead and look here at this first one, and I'm actually going to change one of these, or in fact, I'm going to change them both. Let's go ahead and flip the sign, because I have worked this out already and it's actually pretty boring. I'm going to flip both of these signs. So I want that to be less than and that to be greater than or equal to. If you'll do that for me, it'll make a lot more sense. And that's why we actually listen to the videos and not just turn the video on and look at what I write and just go through that way. So there's no mathematical reason for flipping those. You're never any other time going to flip the signs, but I'm only doing it because I've tried this problem and it doesn't work. Okay, so let's do the first one here in blue. So we're starting at 1, and I want to go up 1 and over 2. And this tells me that it's a dashed line. So I'm going to dash that line, and it goes right here. So that one goes right there. Now let's see where I would shade this graph. So I'm going to test 0, 0. Okay. So the question is 0 less than 1/2 times 0 plus 1? So is 0 less than, that goes away, 1? Yes, it is. So the point 0, 0 works. Now what I do to avoid all this clutter, like in the problem up above, is since I know that I'm going to be dealing with multiple inequalities, I'm just going to draw an arrow or multiple arrows in the direction that I would shade. So I would shade this towards 0, 0. So that means below this line. So I'm just putting these little arrows here that clues me in to shade this one below. And then I'll just do all the shading at the end, just where they overlap. All right, so this one, now I have -2 here. So I'm going to start at -2. Oh, better use a different color. Start at -2, and I go up 1 and over 2. Okay. Now, since it's greater than or equal to, that'll be a solid line. So a solid line goes through there. And that's what we're left with for that line. Let's go ahead and test 0, 0 on that one. So is 0 greater than or equal to 1/2 times 0 minus 2? So is 0 greater than or equal to, that goes away, -2? Yes, it is. Okay, 0 is greater than -2. So I need to shade this one above the line. Okay, so now I just want to shade where those two inequalities overlap. It would be right in here, right in between the two lines. And again, if you remember, I use just lines to shade, because if I actually shade it, it just turns into a big mess, and it's pretty tough to read. The original way the problem had it is that you shaded this one above and this one below, so they didn't overlap. There was actually no solution. Okay, if you don't have any overlap, there's no solution. And the only time that's going to happen again is when we have parallel lines and you're shading opposite sides. Okay, these two lines are parallel, and with our change, we actually have a solution. And if you want to, you can kind of shade the other way. And sometimes I think that makes it look a little better, gives a little checkerboard pattern, and it actually shows really clearly where I'm supposed to shade. All right, let's look at this next one. I promise this one works out without having to change anything. Let's use the cover-up method to graph them. And I'll do the first one in black. So my x-intercept is -4. My y-intercept is -2. If you need help on figuring that part out, you can always ask me. Okay, it's greater than or equal to, so I'm gonna have a solid line here. If you need help going over graphing inequalities, you can either look back at the videos or ask me for some additional practice on those. Okay, and on this one, again, the line doesn't go through 0, 0, so I can test it. If it did go through 0, 0, a lot of times I just pick like 1, 0 or 0, 1. Okay, and so we have 0 plus 2 times 0. Is that greater than or equal to -4? Well, that goes to 0, that goes to 0. So we have, is 0 greater than or equal to -4? It is. Yes, it is. So I'll shade that one above, where 0, 0 lives. Again, just draw a couple little arrows. Tell yourself which way to go. And the next one here, cover up again. X-intercept of -1. And y-intercept of +1. And that's a dashed line because it's just a greater than symbol. So that'll be a dashed line. The beauty is with systems of inequalities is it's not as big of a deal to make sure that your lines hit the right points, because you're not looking for a point of intersection, you're looking at areas of overlapping. So again, I don't go through 0, 0, so I can test it. And so I have 0 minus 0. Is that greater than -1? Well, yeah, 0 is bigger than -1, so that's a yes. So I shade where 0, 0 is. So I can see where my arrows are pointing at each other. It's this way and this way. So my overlap will be right in here. And I know the green's kind of light, but you can see where I should be shading. It's just this area right there. Okay, that's pretty cool. All right, sort of sets up boundaries for sets of points. Let's go ahead and move on. All right, and what I want you to do now is go ahead and pause the video and try these two problems. Okay, welcome back. Hopefully I had a chance to get those done. For the first one, it's already in slope-intercept form, so I'm just going to use that. Okay, I'm going to start at +2. I go up 1 and over 1. Yeah. Sorry, I was having a brain freeze. Okay. And that is a solid line because that's a greater than or equal to. So I'm going to have a solid line right through there. Now, as you get better, you can start kind of thinking this, thinking your test point out a little bit quicker. Something that I'll do from time to time. I'm testing 0, 0, so I'm just going to put a 0 there and a 0 there. And what that means is 0 greater than or equal to +2? Is 0 greater than or equal to 2? No, it's not. Okay, so that means I shade away from 0, 0. Shading up above. I'm just going to put 2 arrows there and there. Gives me a pretty good idea of where I'm going. And this one, I'm actually going to change it into what's slope-intercept form. So I'm going to move the 3x over by subtracting 3x. So I'm going to have y is greater than or equal to. I don't flip the sign because I'm not multiplying or dividing by a negative. I'm just subtracting 3x. So minus 3x minus 2. So I start at negative 2. I go down 3 and over 1. I could also go up 3 and right 1 or left 1. Okay, just to give myself a little bit better idea. Oh, real quick, that is a solid line because that's a greater than or equal to. And so we want to line those up as good as we can and draw ourselves a line through there. And so we have there and there. And again, if I just want to test 0, 0, I can put a 0 in for x and a 0 in for y. And that really means, is 0 greater than or equal to negative 2? Yes, it is. So I'm going to be shading sort of the right side of that line. Okay, and where do those two things overlap? Above this line and to the right of this line, and that's going to be right in here. So that's a good way to not clutter up your graph too much, just by making those little arrows. So if you do that, it really helps you out, and you can just kind of focus on shading one little section. So last one that we have here, I'm going to turn them both into slope-intercept form because they're kind of ugly how they're given to us. Let's go ahead and look at this first one. So I want to move the 2x over, so I have 3y less than or equal to 2x plus 3. And I'll divide by 3 everywhere. Okay, so we have y is less than or equal to 2/3 x, and then plus 1. So I start at 1, and I go up 2 and over 3. That is a solid line. So I have a solid line through there. And again, I'm going to use the original equation to test my point 0, 0. So 0, 0, and that just says, is 0 less than or equal to 3? Well, yeah, it is. Yeah, so we're going to shade down below that line. Now for this one, all I have to do is move the negative 2x over by adding 2x. So I'll have y is greater than 2x minus 3. Okay, so we're going to start at negative 3, go up 2 and over 1. We'll do it one more time. Up 2 over 1. Gives me a little better idea. Real quick, that's a dashed line. Okay, make sure you're paying attention to that stuff. You don't want to get a problem wrong because you made it solid instead of dashed. Or you don't want to have to be creative and have to come up with a way to change solid into dashed either. Okay, I kind of missed my points, but it's okay. I get the idea. All right, I'm going to rewrite my test over here. So negative 2 times 0 plus 0 greater than negative 3. Is 0 greater than negative 3? Yes, it is. So I'm going to shade to the 0, 0 side, the origin side of that line. So it's going to be up above it. And again, I'm just shading where they overlap, which is right in this section here. All right, so another good day. Hopefully you guys learned something. If you need a little bit of help on either graphing inequalities or working with the systems idea, you can definitely ask me. That's what I'm here for. I'm here to help you guys out, and hopefully this is your last section of Term 2. Congratulations, guys. Okay, for the top 5 buzzer beaters in the NCAA tournament, we had number 5, James Forrest, number 4, Bryce Drew, number 3, Tate George, and number 2, U.S. Reed. For this last one, okay, it's probably one of those most iconic moments in tournament basketball. Is Christian Laettner of Duke taking down Kentucky in 1992 The setup for this story is, let's see, it looks like Kentucky is ahead of Duke 103 to 102 with 2.1 seconds in overtime. And let's just go ahead and see what happens. But this is one of those plays that you see over and over again whenever you watch college basketball. It's a pretty iconic play, but enjoy it.
A quick pass to half court and call a quick timeout so they can get in better shooting range.
There's the pass to Leitner. Puts it up. Whoa!